Okay, so I did make a mistake on this one. I just realized that this right here should be opposites. So that should be y here and x here, which is going to change all our points. I was reading it wrong off my paper, because when I did this one, they had the same number. Those were actually the same, so that's correct for D, but these other ones are going to be wrong. They need to be switched around. So this one was going to be 4, 2, and this one's going to be 0, 2. And so now, let's see, we're going to be, just fix this here, get rid of that. So the actual answer should have been, so D is still going to be 4, 4, but now it's 4, 2, so 4, 2 is here, and 0, 2 is here. So that's where they should be. Yeah, something didn't look right when I was graphing it. I graphed it right on my paper, but when I'm showing you guys, I messed up. And so this would be D prime up here, and we got E prime, and F prime is over here. Alright, so number 7. So graph a triangle, which I did already, and we're going to graph its image after a glide reflection. So this one just has two reflection, or two things, a translation and then a reflection in the x-axis. So just do one at a time. So we have the first thing to do and then the second thing to do. So the first thing we do is to the original points. The second thing is always done to the points after we do this one. So we're going to add 2 to x and then just have a y. So here's our first one. And so we have A, B, and C down here. So with A prime, we're going to say 6 goes in, negative 6 goes in here, so negative 6 plus 2. So that's going to be negative 6 plus 2 here. And then y is just going to be whatever it is, so it's 0. So that makes this one negative 4, 0. And then B prime, so negative 3 goes in for x, and we're going to say plus 2. And it's comma 2. It is what the y says it is. And so then over here we're going to take 2 away, so that's going to be negative 1 comma 2. And C prime. So that's going to give us 0 and then plus 2, and then the y is 1, so that stays what it is. And so now we're going to see 2 comma 1. And so that's the first thing we do. The second thing we'll do, so number 2 on this one, we're going to be reflecting in the x-axis, which that means we're going to be doing this. We're going to be keeping the x the same, but y will change to its opposite. That's what we do to the points. That's what we're going to do to these points. So now A double prime will be keeping x the same, negative 4. 0 will stay the same though, because opposite of 0 is still 0. B double prime, so that's going to keep x the same, negative 1, change y to its opposite, negative 2. And C double prime. And so we're going to see 2 is going to stay the same, and 1 will become negative 1. So now we plot these points here on our graph. Let me go back to red here. So I'm going to plot negative 4, let's go negative this way, negative 4, 0 right on the x-axis, negative 1, negative 2, and 2, 1. So positive 2, 2, negative 1 right down here. So now we just connect all of our dots here. And we've got it finished. So my lines aren't so straight when I'm drawing them out. So let's just label these. A double prime would be this one over here, A double prime. B was down below here, so that's going to be B double prime, and C double prime over there. Okay, next one. Number 8. How many lines of symmetry does the regular heptagon have? Heptagon means there's 7 sides on this. It's a regular one, so Symmetry, how much, if we draw a line straight down through the middle, we could fold it and map it on top of itself. So we could see we're going to go, one line's going to go straight through here. Yeah. Another line can go this way. So every vertice basically can go straight through the middle of the other side. That's going to be a line of symmetry. I'll extend those up a little bit. Another one, this one's going to be a line of symmetry going this way. And another one, this will be a line of symmetry going this way. All these are symmetry lines. My lines don't look so nice. These are all going to be lines of symmetry going through here. Probably good if I made had a straight edge, but as long as we get the idea how many lines of symmetry we got, and it's just all the vertices are going to go through the vertice. Each side's going through the sides. That's 7 of those. There's 7 sides, 7 vertices. So that means there just is 7 lines of symmetry. So that one has 7. So this one had quite a few. Sometimes there's not as many. Okay, number 9. Graph the polygon in its image after a rotation of 90 degrees counterclockwise about the origin. So the points for this one that I gave in class are right here. A is 1, 1, B is 2, 4, and C is 4, 1, and we plotted those already on our graph here. We want to do a rotation 90 degrees counterclockwise about the origin. So it's going to go this way. So 90 degrees is going to go this way, counterclockwise is that way. So we want to figure out, okay, what do we need to do to our points? So for this one, for 90 degrees, we just look at that up. Remember, 90 degrees is going to be negative B, comma A. So where B is your y, A is your x. So that's what we want to do to these points. So we're just going to get an A prime doing that. So with 1, 1, we're going to switch them, which doesn't change anything because they're both the same number, but now the first one's going to be negative. So negative 1, 1 for A prime. B prime, we will switch them, and the 4 is going to become negative, so negative 4, comma 2. And then C prime, switch these, the 1 will become negative, so negative 1, comma 4. Those are the points we plot. So we plot these on our graph over here. So negative 1 and 1 goes here, and then negative 4, 2, right there, and negative 1 and 4 all the way up here. So it's going straight down like that. This one's coming up there, and this one's coming down here. And then we can just label these points. So this is my A prime, and let's see, this one was my B prime over here, and this is my C prime right there. So as we turn this around, we turned it around, so B is coming over to this side, C is coming up on top, A is coming around here. It's about the origin. Alright, so going on to number 10, which is a similar one. I gave you these points here in class for A, B, D, E, F, and G. So we plotted those points already here, making this quadrilateral. We're going to now rotate it 180 degrees about the origin. So we got to look up that again. So that's going to be negative A, negative B. Just make them both negative. That's what we're doing there. And so with D prime, so we'll just do that to all the points here. Just going to make them both opposite signs. So they stay the same where they're at, but they just become their opposites. So it's going to be 3, comma, negative 2. And then E prime. So E prime is going to become positive 1, negative 4. And then F prime. So this one's going to become negative 2 and negative 1. And G prime, that one's going to be negative 1, positive 1. So now we just plot each of these points over here. So let's see, 3, negative 2. So 3, negative 2 brings us down to here. That's our D prime. I'll label that one right now. And then 1, positive 1, negative 4 puts me down here. We'll call that one our E prime. Negative 2 going this way, and negative 1 puts us here. That's going to be our F prime. And negative 1, 1 puts us right up here in the middle of this figure. And this one's our G prime. So we're just going to connect the dots together here. Let's see. Try to make the best straight lines as possible. It's kind of hard with this thing, but there you guys get the idea. And just double check here, opposites. Yep. Alright, moving on to number 11. So we're graphing ST with endpoints, and I've already graphed these two endpoints, and we're going to do a composition. We're going to do a translation first, then a rotation. So again, 1 and 2 here. So our first two things. I'll do my first one in blue. So with these 2 points, we got S prime. So we're going to say 3 is X, and we're going to add 2 to it. And then for Y is 1, and we're going to add 2 to that also. So that's going to now give us the ordered pair of 5, 3. And then T prime. And we got negative 3 is the X, and we're going to add 2. And negative 1, and we're going to add 2. So this ordered pair here will be negative 1 and positive 1. Okay, so now we do the next one. So we're going to rotate with these points. So now we're going to rotate these new points we just got. So this was 1. Now this will be our second one we do. Now 270 degrees counterclockwise. That's going to go this direction. Okay, about the origin. We got to remember what to do on that. So it's going to be switching the points here. So we're going to be doing this here too. We're going to say B, negative A. So we switch them, and the X one becomes the negative or opposite. So for S double prime, so we're going to switch these points. So 3 is coming up front. That's going to still be a 3. 3 is coming up front. 5 is going in the back and it's become negative 5. So 3, negative 5. And then T double prime. So that's going to take this one here and put the negative 1, or let's put the 1 comes up front, stays 1, and then negative 1 goes in the back, turns to positive 1. It's just 1, 1 then for that one. And then we just plot. These are the 2 points that we're going to plot. We're always going to plot it after the second one. So now these are the points we plot on our graph that we're looking for. Okay, so we'll plot these points. 3 and negative 5 brings us down here. 1, 2, 3, 4, 5 right down here. That's our S double prime. And 1, 1 puts us right here for T double prime. And we'll just connect those 2 points together like that. And there it is. Alright, let's go on to number 12. So a railway turntable is used to turn locomotives around or quickly change their direction in small spaces. A locomotive enters the turntable on track 3, is rotated 180 degrees clockwise, and exits the turntable. What track does the train leave on? So if he's coming in from this direction here, okay, so he's coming in this direction, and he stops right here. And he's facing this way right now. If the train, if he doesn't turn at all, if there's no turn, if there's no rotation at all, he would just keep going straight. He would exit track 1 if he stayed straight. But since he's going to be moving and it's clockwise, so now this turntable is now going to move clockwise 180 degrees this way. So now it's going to put him facing that direction. So he's now facing this direction, so he's actually just going to go back the other way, the way he came. he's going to be exiting track 3. That's the way he's going to exit. Comes in this direction, he turns around, and now he's going to go back this way because he's going to exit out track 3. So that's all that was for 12. Number 13, in the diagram, the figure is reflected in line A. So that's F right here, reflecting over line A to get F prime. The image is then reflected in line B to get F double prime. Describe a single transformation that maps F here to F double prime. So we want to just go from here straight to here without this. So we want to just have this one going to this one. What could we do? Well, we have 70 degrees on the middle here. We got to take that number of 70 degrees and we can multiply it by 2. So we're going to times this one here by 2. So that's going to give us 140 degrees rotation. So it'll be 140 degrees rotation around or about J right there. So we would just say it's 140 degrees rotation about point J. That's it. So all you have to do is remember to multiply that by 2 to get the rotation from here to here. So that's always, it's a rotation when these are lines that are intersecting. If these lines were parallel, well then it would have been a translation in that case. Alright, so number 14. So find the scale factor of the dilation. Then tell whether the dilation is a reduction or an enlargement. Okay, so we want to look at the, it's always going to be to get the scale factor, always the new figure over the original for the scale factor. So in this case, the new one is where P prime is. So that's a 44. So the new one is 44. And the original is P, so that's the 16. And so we just want to reduce that. 4 goes into both of these. 4 goes into 44 11 times, into 16 4 times. So there is our scale factor, 11 over 4. And since that is bigger than 1, it was an enlargement. So it's an enlargement on this one, not a reduction, because this is more than 1. It's an improper fraction, making that more than 1. Alright, number 15, an image of a celebrity is going to be used on a promotional billboard. The person is 5.25 feet tall in real life and 10.5 feet tall on the billboard. What is the scale factor of this dilation? So again, the same idea there is the original is, is 5.25. The new one is 10.5. So the new one, again, it's always new over the original, or actual, in this case, could be actual. So 10.5 is on top and 5.25 is on the bottom. That's how we make our fraction here, or ratio for the scale factor. That's what it's asking for. What's the scale factor? Which is just going to be this fraction, new over original or actual. And so now we're just going to simplify this, and we should get these decimals out of here. We need to move this one 2 places to make 525 down below on the bottom. And the top one, move it 2 places. That's going to make 1050 on top. And so now we can see that 525, if I multiply 525 times 2, I will get 1050. Okay, because 500 times 2 is 1,000, 25 times 2 is 50. So that's going to make this 2 over 1, or just 2 for the scale factor. So my scale factor is just 2 on that one. Okay, with number 16, a copy machine is set to enlarge an image 259%. If the original image is 3 inches tall, how tall will the enlargement be? And so we want to see, okay, what are we going to multiply this 3 inches by? And so if it's a percentage, we want to get this to be a decimal. So changing that to a decimal just moves that back 2 places. So it's going to be 2.59 times, that's really kind of the scale factor, times 3. So we're doing 2.59 times 3. And so we can see that on a calculator. 2.59 times 3. And it's going to be 7.77. So there's our answer for this one, 7.77, and it's inches. So we'll just put inches there on that one. Number 17. So describe a similarity transformation that maps ABC to DEF. Dilations have center about the origin. And so we want to see on this one, going from the bigger figure to the smaller one, we're going to be reducing it, so our scale factor we know is going to be a fraction. It's going to be less than 1. And so to figure that out, we want to figure out, okay, well, you know, what would the, we can kind of think about the slope, so we want to think of these sides here. So we got DF right here, or we can think of DF and then AC. Those are matching sides right there. Or we can do other ones that would match as well. But if I just did DF here, these are all going by 2s, looks like. Yeah, every box is 2 on this one. So we're going up to here, so it's going to go up to 4. So we're going up 4. And then it's going 1, 2, 3, 4, 5. So 5 boxes, which means that's going to go 10 to the right. So if we do the same thing for this one, if I go up, there's a half a box, that's 1. There's another half a box, that's 2. So it's going up 2. Then it's going half a box is 1, 2, 3, 4, 5. So it's going right 5. So what did we do here? Well, looks like we went from, actually we're going from the smaller one to the bigger one. I was looking at the wrong one on my paper here. So yeah, the smaller one is the original, and the new one we're going to here. So we're going from the smaller one to the bigger one. We're actually enlarging this, which means the scale factor will have to be more than 1. I said that wrong at the beginning. So all you have to do here is multiply 5 times 2 to get 10, 2 times 2 to get 4. So your scale factor is going to be 2. So we're going to have a dilation let's see, dilation by factor of 2. Okay, so that puts it, you know, that increases everything now as we dilate that. And then we're going to see that it's going to have a translation, so then it's going to move as well. So we're going to move it after that. So we could do that dilation first and see where that would leave us, and then move it. So I just, you know, add, you know, if I say multiply every point here by 2, then I can, you know, move these up and see where I would be. So we can see that this point right here is it's 2, it's 3. So that's now going to be 6, and this is 1, so it's going to be, so 3, 1 is going to become 6, 2. So 6 and 2 will be here. So there's my new C point for 6, 2. And this one here is going to be negative 2, and then positive 3 there, looks like. So it's going to be negative 4, and then 6. That'll take us all the way up to here. Now I could do that for all of these, but I really only need to do it to 1, because then I could see from, if this is my C point right here, my new C, or C prime, I could then see, okay, how am I translating it to get down to where actually F is, not E, because C is matching with F. So where am I from going from C now to F? I'm going to go up 2, 4. So I'm going to go up 4. So I'll be going up 4 here, and then from that will put us up to here, and then 1. So that's 2. So 1, 2, 3, 4, 5. It's going to right 10. So we're going 10 this way. So that's what we could say there. We can say it's going to go up, or we're going to go right 10 and up 4. So we can say translation 10 right and up 4. Alright. Now depending on whether they did the dilation first, if they, now on the actual test, if they did the translation first and did the dilation second, then this might be a little bit different. The translation probably would be all divided by 2. So if it's the translation first, so if it was first translation like this, so here's another way we could say or this way. say translation, it could be 5 right, and then 2 up. And then we would say dilation, the same thing, by a factor of 2. So either one of these ways, you're saying this way dilation first, then translation with that, or it's this way. Either one of those ways would work. Alright, number 18 is kind of similar. These ones tend to be a bit difficult because you have to actually see what to do. So we have another dilation that we got to do here. So let's see, W, X, and Y. This is the one I was looking at earlier on my paper. So that's the bigger one. We're mapping it down to the smaller one. So this one is reducing. Here's where it will be less than 1. So again, what we can see is, well, if I can just go from Y up here to X, so I'm going to go from Y to X, which means I have to go from C to B on the other one. So it's going to go, and we're going by 2's again, looks like everything's worth 2. So 2, 4, 6 this way, 2, 4, 6 this way here, it's going to be 6 that way, and then all the way across here, so there's going to be 2, 4, 6, 8, 10, 12, 14, 15, all the way over there to 15. And now I have to go from B back to C, or I should say C to B. So from C to B here, we're going down this way. So we're going to go, looks like down just 1 box, so that's going to be 2. So 2 is there. And then we're going to go 2, 4, and 5. 5 there. So it looks like if we divide these by 3, we would get these numbers. So 15 divided by 3 would be 5. 6 divided by 3 is 2. Dividing by 3 is the same as multiplying by 1/3. So our scale factor would be 1/3. So your dilation by factor of 1/3 on this one. So that's the first thing. And then we're going to see a reflection happening. It's then going to reflect over the x-axis at that point. So if I did put, if I shrunk this down here by 1/3, and shrunk this point down here by 1/3, so this is point 12, 6. So that 12 divided by, I should say 12 divided by 3 here. So we're going to divide each of these by 3. 12 divided by 3, 6 divided by 3. So 12 divided by 3, that would point here, then would become 4. 6 divided by 3 is 2. So that's going to be 4 and then 2. We'll put us right there. So that's the y point. So y is in connection with C, corresponds to C. So as you can see here, C is right here, which is 1 away from the x-axis. This is 1 away from the x-axis. If we do that to all our points, we will find that they'll be all exactly the same kind of distance away from the x-axis. This B right here is 2 away this way. So the other one here, this new x point, will come down. It'll be right about there. So this is going to be a reflection in x-axis. So there's the two things you would say for that one, describing that similarity transformation. Okay, number 19, you want to enlarge a picture by a factor of 2.5 from its current size of 4 inches by 6 inches. So what's the size of the enlarged picture? So all you got to do is just multiply 4 and 6 by 2.5. That's not hard to do. So it's going to be 2.5 times 4 for the 1. So that's going to just be 2.5 times 4, that's going to be 10. So we'll say 10 inches on this one. And then the other one's going to be 2.5 times 6, and that's going to be 15. So 15 inches for that one. So you can just say there's our answer. 10 inches by 15 inches. All right, number 20. Now we're getting into our matching. So we're matching on 20. We have 20, 21, and 22. We want the component form of AB. So A, B right here, the component form. So that's going to be one of really these two, either A or E, because those are the only component forms that we have here with these kind of, not parentheses, but kind of V's, sideways V's there. This one's going to be going from A to B, so it's going to go 1, 2, 3, 4. So that's a -4 this way, and then down 1, -1. -4, -1. That's E right there. So number 20 has got to be letter E. Component form again for the vector that would map point A to point F. So A all the way to F. If I drew a vector from here to here, what's the component form? Well, there's only one component form left, and it's this one here. And that should make sense because we're going to go from here, we're going to go left 5 from A all the way over to where F is. That's left 5, -5, and then up 4, which is what A is. So that one's got to be A, another component form. 22, composition resulting from moving point B 2 right and 6 up, then 4 right and 2 down. So we don't really have to worry about point B. We're just going to add these kind of up. So 2 to the right is +2. So we're going to see, I'll put over here, let's see a +2. And then we're going to see for what else is right? 4 right as well, so it's a +4. So we're going to add 6 then, so it's going to be x plus 6. We can kind of come over here and see which one has that. So x plus 6 is right there for C. This one has x minus 4, so that can't be it. Has to be letter C. We can just double check it with the other one though. 6 up, which is +6, and then 2 down, which is -2. So that's going to be 4. So yep, +6 plus 4, letter C. So 22 is letter C. And then for our other ones over here, 23, 24. So our triangle has these vertices. We're going to match the scale factors here to which ones the prime ones would be. So if we have a scale factor of 3, it means we multiply all of these by 3. So if I just multiply 10 by 3, it's 30. The only one that has 30 is letter A. That's 25, 13, -20, so it has to be A, so 23 has to be letter A. And then scale factor at 250%, which means, move that decimal back 2 places, 2.5, multiply by 2.5 then. So if I multiply 10 times 2.5, that's going to be 25. So that's got to be letter B on that one. The only one that has 25 there is letter B. So those ones went really quick. Alright, well that concludes our review. Keep studying for the test, and good luck. I hope you do well.